yesterday.
Okay.
And she switched my pre-cal class from this period to fourth period.
Okay.
But I needed it switched back because I didn't check with my parents and it interferes with my schedule that we already have in place.
Okay.
Am I taking off your roster for this period already?
You have to tell me your name again.
Colin Bachelor.
Colin what?
Bachelor.
With a B?
Yeah.
I'm not seeing you there.
Yeah, okay.
Yeah, you need to follow whatever schedule you have right now, though, because I can't say that you're here if you stay in here, and your other teacher's going to count you out.
I was just letting you know. Well,
Okay.
she switched, like, I had Jack, like, I had the free period
Okay.
instead.
Okay, I got you. Oh, in that case, you're welcome to hang out. I don't know.
I don't want to miss anything.
Okay, let me see if there's... Yeah, go ahead and just sit in your seat that you were in last time. There is a couple handouts, and you guys do need to borrow a textbook today. So if you forgot those things, please go get it before class starts. Piper.
I got this sign,
Okay.
and I have this other
On this
thing.
one, I want you to keep this in your binder in case you want to refer to it. Did you sign it digitally by going through those links?
The student signature, that link does not work.
It didn't work? Okay, I'll double check it. But keep this in your binder for now. Just have it where I can ask for it.
And then I have a thing for my choir
Okay. What's this
that I
for?
have for you to sign. I'm like in this special group now. We don't know which advisory it is yet. That's why it's blank.
I don't know what this agreement is, so I don't know what it's asking for.
It's sort of like just acknowledging that I'm like in this group and that like I'm trying to think of how to say this. It's mainly because since we'll have advisory time, it's just letting you know that I also have a thing outside of class, and then I might also be occupied during advisory for this class.
Okay, sometimes. Well, like if you need to make up a test or you need to get extra help or something, you're still obviously on the hook for coming here, but
Thank
make sure you
sir.
put your name on there too.
Yeah.
And keep this, please.
Yeah.
Okay, guys, sorry, I tried to announce to a few of you guys, but there is a couple handouts this morning. So those will always be on the front desk, so if you didn't know to grab those, that is okay, but please go get them. Also, there's a sign sticking up that says you will need a textbook today. So on the bookshelf, well, unless you brought your own book, which I don't know why you would, just grab one of those books on the bookshelf, and you can use it during class, and you can put it back at the end of class. But for us to get going this morning, there's a few things I need you to get out. So notice under bell work, I need you to get out 3 and 4. So this is where it's helpful to have these things numbered. 3 was your notes that we started last class. We're going to finish those up today. And 4 was the book assignment we started last class. We will also be finishing that up today. So you need to have both of those out. And I need one more thing, which I would normally put under bell work, but I haven't told you guys where to turn in physical copies yet. So last class, the very first thing you did was the Getting to Know You handout, and I didn't want to take that up from you. Last time, but I'm going to collect it today. So actually 3 things. Find 3, 4 in your binder. If your binder's already put together, that should take you about 10 seconds. But also find the Getting to Know You page. It's not online, it was one of the handouts on the desk last class. Just bring it. Bring it as soon as you can, but you'll have to like put it over there. Okay, so with turning in assignments, last year I tried a new thing where I made it optional if you wanted to turn it into Google Classroom, and I'm still going to make that available. But when or if you have to turn in physical copies, I've got a little metal box here. Those of you that get here early and you see that you have to turn something in, a lot of times students just come over here and just go ahead and turn it in. I don't want you to all get up and do that right now, but sometimes I also just sit it right here. So let me grab the Getting to Know You handout. I will put that away. Put it in that box next class or stop by and do a sooner. When you're done, just put it in this little basket. That's everybody. Okay, so the main 3 things we're going to look at today is we're going to finish up those notes we started last time. So we did a few of them before, just so it wouldn't be quite as much today. It will take me just a minute to get attendance put in. Brandon is late. 2, 3. Okay, sorry about that. As I figure out your names and stuff and get familiar with our seating chart, it doesn't take me but a second to do attendance. But so there is one big change this year that I didn't mention last class, and we didn't put it in the syllabus, but you guys should be aware of it, I guess. We do allow semester exam exemptions in this class if you meet the requirements. But the requirements have changed from last year. This will be school-wide, so you should hear this from your other teachers at some point too. It's still above an 80 grade-wise, no discipline stuff, no ISS, no Saturday school. Last year you could not have more than 10 absences. This year it's no more than 4 to exempt, and you cannot have more than 4 tardies. I'm pointing that out to you on day 2 because this being the first class of the day, tardies are very easy to come by. So if that is important to you, you need to make sure that you get that sorted out, please. Okay, so first thing we're going to do, let's finish up these notes. I think the last thing we talked about, but you guys can correct me here, was coterminal angles. I think we finished that little section. Correct? Okay. All right, so we still need to talk about complementary, supplementary, how to work with degrees, minutes, and seconds, and something called arc length. Then we will have a good chunk of time to work on the book assignment. Although I don't know that you would remember, because I know first day you guys hear tons of information, but one change that we have is that we were planning on having this first quiz the 3rd day of class, which would be Friday for y'all, but that has been pushed to the 4th day of class. So me and Miss Thomas, the 2 pre-cal teachers, we just agree on all that kind of stuff. So since she's doing it on the 4th day, we will also be doing it the 4th day. If and when that stuff ever changes, I always put it on the far right over there. So our slide from last class. You can see I was expecting it on the 18th, but now I'm expecting it the 21st. So I always try to keep that updated. So again, that's a quick way. If you're at home and you don't remember if there's a quiz or when it's going to be or when's your test, that's usually just a quick way to check that, and that's on our class website. Okay. So complementary and supplementary angles, this is really just an extension of what you did in geometry, and I believe these vocab terms come up in the ACT as well, so it's a good review for that. But complementary angles are angles that add up to 90 degrees, but realistically, when we're working with radians, we really are more interested in them adding up to pi over 2, which is of course the same thing. Now, almost kind of tricky, but I think 1 or 2 of your book questions will be like this. By definition, complementary angles have to be positive. So 100 degrees and negative 10 degrees are not technically complementary. They both have to be positive angles. Okay, and so there's a few different ways we could ask that. What angle is complementary with 15? So
75 was.
okay, 75. Try to sound a little more confident here. What about 89 degrees? 1. What about 91 degrees? They have to be positive. 2 positive angles. So this one's not possible. Now, I like to fly through the degree ones. You can see y'all didn't struggle with that. Simple arithmetic in your head. But radians take a little bit more work. Most people can't tell me what to add to pi over 3 to get to pi over 2. So if you're good with fractions and you're fairly familiar with the unit circle, some of you maybe could. But let's talk about why these first 2 worked, and then we can apply that logic to these 3. So what I was trying to figure out is what could I add to 15 degrees to get 90 degrees? It's just that was a simple one step, so I didn't really have to write that out. I could just do it in my head. But over here, what could I add to 89 degrees to get me to 90 degrees? Because 90 degrees is what it means to be complementary. So when we do pi over 3, we can think of this the same way. What can I add to pi over 3 that gives me pi over 2? Because pi over 2 is the radian equivalent. If this is in radians, you want this to be in radians. You want the units to compete or match up. So then you can see you could subtract this over. And you may need to get a common denominator. And you would get pi over 6. So if you can do that in your head, more power to you. But most of us need to physically write out that equation, and then you've got something that you can solve. Okay, so I would like you to take just a moment and try that on these two. This one should be very similar to this one because it looks kind of the same. The next one, I just want you to kind of see what you would do before I tell you. So I'll set a timer just a minute or two, just long enough to give it a good shot. Then we'll practice a couple with supplementary, and then that should be sufficient for that. Okay, so if you can think of what you could add to pi over 9 to get to pi over 2, that is wonderful, but myself included, I don't know if I would trust myself to do that. So force yourself to write out what we're trying to do here. We're trying to figure out what we could add to that angle to get pi over 2, because that's what it means to be complementary. Then you could subtract this over. And again, I think I mentioned the first class, especially the first few weeks, we do a lot of add, subtract, multiply, and divide fractions. So I get it if you're rusty, but you need to make sure you remember to add and subtract fractions. You need a common denominator. 9 pi over 18 is the same thing as pi over 2. And 2 pi over 18 is the same thing as pi over 9. So 9 pi over 18 minus 2 pi over 18, ultimately 7 pi over 18. You okay with that? Okay. Okay, and then 1 radian. So radians, I think you may have seen one of these in your textbook last time. It wasn't one we got to together. But radians most of the time are in terms of pi, but they don't have to be. Radians can also just be numbers like this, just 1. The nice thing is, if you take this approach, and again, I've been teaching pre-cal for like 11, 12 years, so I usually know the method that students think are the easiest. Do the same thing with this one. What can I add to 1 radian to get pi over 2? Because if you do that, that's even way easier than the question before it. Subtract 1, and there is your answer. Pi's and a constant are not like terms. You can't force those together. It's even less work. I know it feels a little bit less comfortable, but this is why I'm trying to emphasize this way. What can I add to that angle to get it to what I want it to be? If you do it that way, you just give yourself an equation to solve. Okay, so complementary angles add up to 90 degrees, which is the same thing as pi over 2 radians. Supplementary angles add up to 180 degrees, which is pi radians. So if you understood the steps and the process I took on these, then this will be very similar, except I don't want them to add up to 90 or add up to pi over 2. I want them to add up to 180 or to pi. So what angle would be complementary with 80? Okay, 100, very good. And 120 would be, thank you. And 210 would be not possible, because by definition they have to be positive angles. So degrees, most of the time you guys answer those real quick. Radians, not so much. Can anybody tell me what you think the supplement of pi over 4 is? Does anyone have a guess? One more time? No, I think that's too small probably. But thank you for guessing. Anybody else want to guess? Okay. Do what? 3 pi over 4 is going to be correct. So, I can kind of visualize this one because I know where pi over 4 is. I know it's a fourth of this, so if I'm trying to get to this, I need 1, 2, 3 more of those, 3 more 4s. But you don't have to do that yet. In a couple weeks, you might feel comfortable doing that. But for now, don't risk it. Say, what can I add to pi over 4 to get to pi? Then you've got an equation. You can undo the add with subtract. Yes, you have to get a common denominator, but 4 pi over 4 minus 1 pi over 4 should leave you 3 pi over 4. Okay, so same thing we did before. I know there'll be 1 or 2 of these in the book for you to practice, but please try these 2 real quick in just a moment or two, just to give yourself some quick feedback and maybe give yourself a quick chance to ask questions. So try the 2 on the right and we'll move on. Okay, I'm not giving you quite as much time because this one had a little bit of a cheat to it, right? What angle should be supplementary to 3 pi over 4? All right, we just did that right here. If 3 pi over 4 is the supplement of pi over 4, then pi over 4 is the supplement of 3 pi over 4. Let me restart that. Okay, but you could still make the equation and go through that if you didn't notice that. But that's what you should have ended up with. And then one more, radians without pi. Again, I know that seems weird. Seems like radians should always be in terms of pi. They usually are, but they don't have to be. So just force yourself to say what plus 2 radians, it's not 2 pi radians, it's 2 radians, just the number 2, gives me pi. Then all you have to do is undo the plus with subtract. These are not like terms, so you cannot even combine them together anyway. So just leave it as is. All right, so this question type can be pretty easy if you remember complementary means add up to 90, supplementary means add up to 180, and if you now know 90 degrees is the same thing as pi over 2 radians, and 180 degrees is the same thing as pi radians. But before we move on from this, is there any immediate questions or concerns, anything you want clarification on?
Where would you put 2 radians on like a unit circle, on that circle?
I couldn't do 2 radians exactly, but I can estimate it okay. Because right here is 0 radians, right? The angle doesn't open up at all. If you go halfway around, how many radians is over here?
Halfway?
Halfway.
Half a radian? Or 1?
Okay, how many radians is all the way around? Because that's the one you have to memorize. Not 2. 2 pi. Very big difference. Number 2 means 2. 2 pi means 2 times 3.14, blah, 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 blah. So if all the way around is 2 pi, halfway around is 1 pi. So there's that. Now, if you think of pi as a decimal, it's about 3.14. So this much of a turn is about 3.14 radians. Then 2 radians would be, I don't know, roughly about there. I couldn't sketch it perfectly. But 1, 2, 3, about 3.14. Very good question, though. Okay, degrees, minutes, and seconds. So next topic. This is also, some of these guys, this stuff just, we start with this stuff because it gets sprinkled in all year. Even in like March, you'll probably have a book assignment where 1 or 2 questions are in degrees, minutes, and seconds. And if you remember this, then it's easier. And if you don't, then it's just one more thing you have to relearn. But degrees, minutes, and seconds is very common in real world stuff. If you ever look at a map, latitude, longitude is written in degrees, minutes, and seconds. So big world navigation stuff, airplanes, ships, all use degrees, minutes, and seconds. So that would look something like this. You might have 5 degrees, maybe 18 minutes, and maybe 34 seconds. That's how that reads. 1 tick mark is for minutes, 2 tick marks is for seconds. And I'm going to show you how you would work with that when you see it. You would need a calculator to do much with it. Whereas a decimal degree is just where it's going to be like, I don't know, 34.178 degrees. A degree that has a decimal. This is a little bit easier to work with because we can just throw this in the calculator. In theory, you can throw this in your calculator, but unless you memorize where these minute and second symbols are, and I don't even do that, you can't really do that anyway with the calculator. So. Okay, so my preferred way to go from degrees, minutes, and seconds to just a decimal degree, which is what we will use. We're going to use this example down here. You have to know what this is saying. If you have 60 degrees, that means you have 60 full degrees. If you have 34 minutes, well, a minute is a 60th of a degree. So we've got 34 of those. 60 minutes in an hour, so a minute is a 60th of a degree. And then seconds, we've got 54 of those, and then we divide that by how many seconds are in an hour. So 60 seconds per minute, 60 minutes per hour, so how many seconds per hour? So 60 full degrees plus 34 minutes, so plus 34 60ths of a degree, plus 54 seconds, which is 54 3600ths. And then what you would have to do is you have to type all that in your calculator. I know most of you don't have a calculator in front of you, so don't worry about it. I'll just do it real quick. And that will change it to a decimal. So it's going to be pretty close to 60. It's like you're doing 60 plus a tiny bit more. But if we were working with this question, I would just work with this decimal, not use all of this mess. Okay, I'm not going to take the time to talk about where you can find these symbols in the calculator. If you really like dealing with calculator and that kind of stuff, you can find those in the menu. I could probably find them fairly quickly, but it's completely optional. You don't have to be able to do it that way. You do need to know this, though. That way you can work with those. Okay, to go the other direction, we don't have to know anything except that our calculator can do it for us. So your calculator has this built-in function that says arrow DMS, which basically just means change to degrees, minutes, and seconds. So if I want to change 60.54 what you would need to do is you would type in 60.54. Not right now. Just hold off just a second. If y'all need to borrow one of my calculators later, I've got some up here, but let's just wait. Then you have to know where that is in the menu, and I think it might be like under math, somewhere in here. Honestly, I don't ever remember where it is there because I like to use the catalog. So down here, if you hit second 0, the catalog has everything and it's alphabetized. So if you go to D's or you just hit D, you don't have to scroll very much till you find Aero DMS. Hit enter, it puts it on the home screen, and then if I hit enter one more time, my calculator understands I want to take this decimal and change it to degrees, minutes, and seconds. And it will handle the rest. So pretty much you just have to know your calculator can do that, and you have to be able to find it. But if you do like I did with the catalog, everything's in the catalog, so you'll find it eventually. But it is alphabetized too. So. But if you want to add a couple words to how I did that, that might be beneficial to you for your notes. Technically, you can also get this with a little bit of guess and check. Like, you know, it's probably 60 degrees, and then you could guess a minute and see what the decimal is, and then increase it and see what the decimal is, and then if it's too big, you lower it, and then you move on to seconds. So you can kind of do it with guess and check, but again, I just want you to know that's possible. Realistically, just let your calculator do it. But I typed out the process if you're interested. So degrees, minutes, and seconds. Lots of real world stuff is going to be written that way. Again, this type of question gets sprinkled in all the time. So a couple in our assignment today, but also in a couple weeks when we're doing a totally different topic, some angle is going to be written this way, and you need to know how to change it. So if it's written this way and you need to change it this way, just let your calculator do it. If it's written this way, you've got to know what a minute is and what a second is. 60 full degrees plus each minute is a 60th of a degree. Each second is a 3600th of a degree. Just type all this in your calculator and it will change it to a decimal for you. Okay, last up, and then we can move back over to the book assignment. So hopefully you can get all that finished in class. So we do take off a couple things. I think I mentioned last class the 5th vocab check was about linear speed and angular speed, so we don't make you do that anymore. But we still like you to do arc length, which is just one kind of small application of some of this stuff, just to give you some sense of why you need to be able to work with radians, other than people tell you to. Okay, so circumference, the distance all the way around the circle is 2 pi r, whereas arc length we use the letter S, is only part of the distance around a circle. It's part of the circumference. We use this little formula to work with it. Arc length is equal to the radius times theta. But I always tell my students, now I didn't have any input in the design of this textbook, but my theory is the reason why they talk about arc length in the very, very first section of pre-cal is that it gives you an example of when you need to use radians. This formula only works in radians. If you put a degree in here, it does not work. It has to be a radian. So for this example, let's say that this guy had a radius of length 2 inches. We're doing this example. And then let's say that his arc length has a 45 degree central angle, so that's the angle at the center. We can use this formula to figure out this distance, part of this distance around the circle. So you just say arc length is equal to radius times theta. And if you do this on the quiz or the test, you're probably going to tell me 90. Even better would be 90 inches, but that is not correct. This is about as easy formula as you're ever going to get now that you guys are getting into higher mathematics, but it only works if theta is in radians. You can't say 45 degrees. You have to convert that to radians, which is pi over 4. We talked about how to convert that last time, so I'm going to spare you that. So in the end, this ends up being pi over 2 inches. Pi over 2 inches is like not very much, about 1.6. Very big difference from the 90 inches I almost said it was. Okay, and then one more example. Find the measure of a central angle if the circle has a radius of 75 feet. And let's say its arc length is 60 feet. We should be able to use this formula to find out how much of an opening that angle has to have. So, only formula I've given you that ties all of these things in together is S equals R theta. We know S, it was given to us. Include the units here. You'll see why in just a second. R was given to us, and theta is what we're trying to find. That's why this is a good formula. Okay, and then to solve, just undo times with divide. And 60 over 75 reduces to 4/5. But notice, since I kept up with the units, do you see how the feet are going to cancel out with feet? The units go away. Well, what happens if we don't have units? It's implied radians. Remember, radians are the blank unit. So if all of your units go away, that means your answer is in radians. Now again, you don't have to write radians for this to mean radians. This means 4/5 radians as well, but it's in radians because all of the units went away. So, good formula, but make sure your angle's in radians, not degrees. That's the biggest mistake there. Okay. Of course, you may see that you have some questions on this later, but any questions you have about this ready to go, you want quick clarification on. Okay, then the next thing we need to do is we need to move along in the book assignment. So some of the questions you guys should have skipped last time were about complementary, supplementary, but now we did a few of those in your notes, so you should be able to attempt those now. A few of them you skipped last time were degrees, minutes, and seconds, so you should be able to attempt those now. There are a couple that you will eventually need a calculator for, so if you do not have your own calculator and you need to borrow one from me, you can come help yourself here. You just need to put it back at the end of class also. Don't leave it on your desk. If you borrow one from here, you're responsible for it. And if you know you need to borrow a calculator, just go ahead and do that at the start of class when you remember, because you will need it most days. So what I'm going to do is give you guys a little bit of time where I will shut up and let you try a few of these questions, not being distracted. Then I'll come around and help out some individually and see how it's going, see if there's any common questions that we need to talk about on the board. Probably will be a few that we need to do on the board. But before I completely shut up and let you be productive here for a moment, the handout that you guys picked up this morning, all of those make up number 5. It is a 4.1 worksheet, and please don't work on that until after you're done with the book work. Finish the book work, then you can try that. But one page of that, it was 2 pages, right? The first page of that, the one that's not 4.1 worksheet B, just 4.1 worksheet is first. You really should use that kind of as a practice quiz. We don't give a practice quiz for all of our sections, but once we're now done with our notes and once you're done with the book assignment, it's good for you to try it and then see, like, this is about what we're going to be expecting on our quiz next Monday. Helps you identify what questions you might need to ask about, what things you might need to review. But for those of you that remember some of this from last year, or you just catch on quicker, you finish the book assignment quicker, I am going to ask that you work one of those 2 pages on number 5 between now and Friday, so you should use your class time if you get to it. If you don't get to it, then of course you just have a little bit more homework. But. Okay, so as promised, I will let you get your feet wet here and get a few questions under your belt, and then I'll come around the room here in just a bit. It wants your answer as a multiple of pi. So your answer should be like pi over 4. Your answer should have pi in it. What they're saying is don't go into your calculator and do pi divided by 4 and write it as this. Again, I know some of you have not used a math textbook in years, but in the back of the book has the odd answers, so it's pretty easy, especially if you just take like a post-it note and you put it on the page it is. Every time you work an odd question, flip to the back. If it's right, it's great. Don't put any more thought into it, but if it's wrong, you might want to revisit it a little bit before you move on.
So you can add 0 or 360 or 3,600 if you want to.
That's why I like the side.
No, they're just not. Most of the time it's not. Over here. I see anything yet?
So, line 15A. So we have 15, 16,
You check your stuff in Radiance the whole time, so your answer's still in Radiance, so that's fine. It's just that like some people prefer to convert it to degrees because they feel more comfortable, and then it's easy to answer like, what's the complement and supplement if it's in degrees, like how we did this quickly. But in mathematics, there's a understanding questions in degrees, your answer should be in degrees, if it's given to be in radians, your answer should be in radians. So if you go that route where you want to convert it to degrees, to make that part easier, you just have to convert it back to radians. If you do it the way you did it, you don't have to do it that way. Okay. Are you just, are you converting it? Is that the question that you do? So what this is to change it from radians to degrees and degrees to radians. So you're thinking of a different question. Complement and supplement is like what we did right here. Complementary add up to item 2. So you say what plus this is item 2. Like solve your equation. Yeah, exact same question. Yeah, that's what you said. Okay.
Those are the figures. That's the only way you can get some quick up line.
Okay. So is that 4 degrees or 4 radians? Good, because it doesn't say degrees. So what you have to do for this one. How many radians is right here? How many radians is all the way around? Okay. So half of that would be here, half of 2 pi would be 1 pi, okay? And pi as a decimal is about 3.14. So if you want to sketch 4 radians, and you know from here to here is about 3.14. 4 is going to be a little bit more. That's supposed to be right. Okay. Okay. Well, the same way that you converted that to degrees, you multiply by this to convert your radian to degree at the start of the problem. Well, if you multiply by the reciprocal, you can change your degrees back to radians. Anybody over here down on something? Yes, sir. On the For complementary? Yeah, I would say what could I add to that to get the pi over 2? But that one's going to be kind of weird because this second half of the question, the supplementary sugar question, you could say what plus 11 pi over 12 equals pi. All that you got to
I don't understand how to take the degree to radian.
So that's what we talked about last time. If you've got degrees and you want radians, you have to multiply by this. And if it's a decimal like that, you just have to use your calculator. Right here, you guys have anything jumping out at you yet? So this same thing we did last time. I think we did some of these questions up here as well. It's just that these you have to use a calculator for, just based on the numbers. So in your notes, so you've got something in radians, 1 degrees. So you need to multiply by 180 over pi. But based on so type it in your calculator. You're not going to be able to do that by and then multiply by 180 divided by pi, and you get a decimal answer. So then divide by pi. Well, you multiplied by pi and divided by 180, so you want to go from degrees to radians? Yeah, you're right. Yeah, that's it. Yeah. It's the exact same process as earlier questions, just that earlier questions like work out a little bit nicer so you didn't need to use calculator. That's messy or decimal, you have to use calculator. If it says round to 3 decimal places, you should multiply by. If it says leave your answer in terms of pi, then don't multiply pi and just leave it next to it. Okay, so where's it in your notes? So you didn't write that down. That's why it's not on there. You gotta take all the degrees that you have. So I did 60 plus. You got, okay, so we calculated 54 plus. Okay, then you have to know that a minute is a 60th of a degree. So I did plus 34 over 60. I don't know what you're looking at. So and then plus, if you have any seconds, seconds are over 3,600, so I added, okay. So if you want to, you could say plus 0 over 3,600, but that's going to be 0 anyway, so why bother? Okay, hit enter, that's it, very good. Now it's a decimal. But you need to update your notes here, because you might need to look back at that.
I'm so confused on how to convert from that.
Okay, you gotta show me a question, or you gotta do another specific. Okay. What's the question? I don't have these memorized, so I don't know what to start with. Okay. Alright, well you don't have to convert it at all if you don't want to. It's a different question type. Complementary and supplementary is what we did here. So you write out an equation like I did in the notes. Okay. Okay.
shift, so you'll need to practice this as soon as possible. You got this. This, I think. So you don't have to do this to multiply and divide fractions. To add and subtract, you have to have a common denominator. So the lowest number that I can make 2 by 12 be is 12. Okay. This one already has that as a common denominator.
So then I have to do 2 higher.
Okay, well, what do I have to multiply 2 by to get to 12?
6.
I multiply the bottom by 6, multiply the top by 6. 6 pi over 12 is the same thing as 1 pi over 2. Now you've got 6 pi over 12 minus 1 pi over 12, which is 5 pi over 12. And then that's what you should do. But you add or subtract, you have to go through the
And again, that one's kind of like practice quiz. I'm not finishing that. There's one right here and one right there.
Do y'all have questions that I can help with, or will be up there?
So how did we last class convert from degrees to radians? Earlier you said, I think they gave you nice whole numbers and stuff to work with, so you could just do that. Using your phone or if it's maybe on board, so you bring it up. The only goodness is here, since these are messy decimals, you'll need a calculator. So put that in the calculator, do the times pi over 180 or times 180 over pi in the calculator, and you'll officially agree with it. Same process, but it's actually meant to be easier.
I'll get you one.
There's something holding back. Yes, well, you have more specific than that. You might want to reread your notes then. I can't do all of Monday again for you. See if you can find a specific question. Y'all have something I can help with? I know some of you guys are finishing up with the bookwork. Again, I am gonna ask that you do one of these pages on number 5, which you picked up today for homework. So those of you that are already done with the bookwork, obviously you should just move on to that. And please treat that like a practice quiz. Try it without your notes, without asking me for help, without asking your neighbor, working with your neighbor. Just see where you stand. This, you can. But also, did you bookmark my class website? Okay, it's always in the top right there. It puts it there automatically. Now, it's kind of small, but I think if you click in the right spot, it'll make it full screen. But yes, you're always welcome to take a picture of anything. If it doesn't say degrees, we assume it's radians. No units, it's radians. Stapler? I just did it on this one. way down to these at least. It saves you a little bit of time.
So those two ones, how do you know if it's like before
Well, what is pi as a decimal? Okay, so we know it's before pi. Pi is 3.14. What's half of that? There you go. So if it's bigger than that, it's bigger than pi over 2. If it's less than that, then it's less than 1. And you just have to think of it as a decimal.
So for the column, it's pi instead of pi over 2. So or, oh wait, there's some.
Complementary means add pi over 2. Supplementary means add pi.
So I got the backwards. How would I do? So how would I do the same thing with pi? Because it's not a fraction. It's just pi.
Sure. So like if we did the exact same thing here,
Or it's 11 pi.
well, you still need a common denominator. So this guy needs to be
12.
multiplying the bottom by 12. You have to multiply the top by 12. And 12 pi over 12s minus 11 pi over 12s. These are like terms. It's going to leave you 1 pi over 12. Same thing, it's just that instead of starting with pi over 2, you start with pi. But you have to remember which one's which, because if you mix those up, then you'll miss all of those. And it's only a few points, but still.
I want to interrupt you here for just a second. I didn't get any. Yeah, but wait till I say this so you know. Remember last class I did have you guys bookmark this website. This is our class website. I just want to point out a couple things. I know I said it last time, but you guys are swamped with information. I really don't feel like you need to do this during class, because as you guys find questions in class, over time you might work with your neighbor, or I can help you on the board, or I can come over and help you. But if I'm busy helping someone and you're being impatient, or if you get home and you still have a couple more of these to do, or you're struggling, remember I do have every single one of these book questions worked out. Each one is an individual video. And I guess in class, some of these questions you can't check the answer to. Like number 40, the back of the book doesn't have the even answers. So obviously you can't play these in class with sound or anything, but if you have your sound off or if you have earbuds, this one's only a 31-second video, but if you just wanted to check your answer, you could just kind of skip to the end and see if you got the same thing as me. But again, you don't need to utilize those in class because you have me to ask. But if I am busy helping somebody else, or you think you might want to pause it or rewatch it a few times, feel free to pull that up on your Chromebook. And the one other thing I wanted to point out, so the worksheet that you guys picked up today, if you get to that in class, that is great. And if you don't, please try one of those pages. So right here is the solutions. I want you to treat it like a practice quiz, but if you're missing half the questions, I want you to get that figured out before you take the real quiz. So you should go here, click this, it will download the solutions. You can see if you're doing it right. You can see which questions you're missing. If it happens to be question 1B, 3B, 4B, 6, 7, 8, or 9 or 10, those are the ones students have asked in the past. There's already a video there, and you can get help with that if you're outside of class. Of course, inside of class, you can just go ahead and ask me. The other page that you got is the worksheet B. Same thing. I don't have videos of it, but I do have the solutions. So you don't have to do the worksheet B between now and Friday, but you need to do the other worksheet to see where you stand. Anyway, I just wanted to point that out so you guys know how to best utilize that. For the pass, either leave your phone or put your name on the board, take the pass, and then take your phone or your name off the board when you bring it back. And you'll still have about 20 minutes. There's still quite a bit of time here. I'm gonna make my way back around the room. So if I'm near you and you have a question ready, please call me over. You need to borrow a calculator? I've got some. It's fine. We just normally don't need more than 10, so I don't keep a lot. This is one of my personal ones. Let me get some batteries. I'll bring it to you.
Thank you.
start on the positive x-axis. If it was 8.3 degrees positive, you would go counterclockwise a little bit. If it's negative, you just turn the same amount but
So
clockwise.
then it would be four.
It'd be in the fourth.
Is it 1, 2, 3, 4?
The pen's pretty hard, so. Just a warning. Well, you could convert this to degrees, and that's going to be easier. Multiply by pi 180 or 180 over pi, which will be better. The other thing you can do is you can think of these here instead of pi, is about 3.14, so 2 pi would be about 6.28. So, is yours closer to 3.14 or 6.28? That would be this part of 3. You guys noticed that your classes are a little bit longer this year? Extra 10 minutes. Pretty good for this class, because that means you should have a little bit less homework. I try not to give too much homework, but a lot of it just kind of depends on how much you get in that class and how well it's sticking and how much you have to review it and study, but that 10 minutes certainly does add up. I will say for those of you that have already made it to the practice quiz, when you get to the last question, it's the only one that's not just can you do the skill that you already practiced in the book. It's a little bit of an extension. So we'll talk about that one for sure together on Friday, but in the meantime, I'll give you a hint that you should make a picture. If you're stuck on the question 10 on the worksheet, try to make a picture and see if you can piece together some of what you need to do. It's the same skills, it's just not, you're not being told what to do. It's can you figure out what to do. What's your question? I can't help you if that's what your question is.
I'm sorry, I'm trying to think of it.
That's fine. Formulate your question, I'll be back around in a few minutes. Anywhere? Oh, you're getting close. Really optional, but those of you that are working your practice quiz, I think it's a good idea to circle or highlight the questions that you miss
or you don't remember how to do, because those are gonna be the questions that you might miss or not know how to do on the actual quiz. So do something so that you remember when you study for our quiz what you actually need to look back at. Also, I have a big box of highlighters up here, so anytime you guys ever want to borrow highlighter or 5 for class, you're welcome to them. Just take what you need when you come out of class and put them back so they're there the next time. Figure it out.
So, 5 materials, I converted it to 450 degrees.
Okay.
So it says to try the same position. Is this correct? Like, is it, do I do it like a? Yeah.
Standard position, you should show that you start here. Okay. And then from here to here would be, so this is, and then another 90. Oops. So what you should show is that you start here, you go all the way around, plus another 90, and in here. And all that. And that's fine. Again, a lot of these questions you guys can work multiple ways. So try to stick with what seems the most intuitive to you. But when I draw like a circle, you know where pi over 2 is?
Yeah, it's on the top.
Okay, so this is where 1 pi over 2 is, from here to here. You can turn that much again to get to 2 pi over 2. Turn again to get to 3 pi over 2. Again to 4 pi over 2. And again to 5 pi over 2. To me, that's a lot faster than converting.
That makes more sense, but I'm also kind of confused with the numbers in front of the pi. Like, I don't know. Those kind of confuse me a little bit. Like, 5 pi over 2.
It just means you have 2.5 pi. Just being multiplied together. Man, you're close. You might get it. From what I can see, the few people that have already worked to the bottom of the worksheet, that question 10, looks like y'all are doing pretty good with only one hint. But again, we will definitely talk about that one next class. This one that didn't match up with the book and didn't match up with our notes. So the other side.
240 is formula only works in radians. 240 is the same as 4, 5, and 3, so you converted that correctly. And then now you just need to multiply it fractions. So 25, I think. 25 inches. Because the 3 is going to reduce the 15. Well, you're close, but remember this formula only works if data's in radians. So first you need to convert 240 degrees into radians. So that's going to be, you can practice that, but it should be 4 pi over 3. And then you just multiply those together. So you do 15 times 4 pi over 1 times 3. But what's going to happen is 3 is going to reduce to 15 to 5. And so your final answer is going to be 5 times 4 times pi, which is 20 pi. So that's your answer in terms of pi. So that's 20 pi. That minus there should be answers. So 20 pi answers. So you're close. But you have to remember that formula is not going to work in degrees.
Alright guys, we're getting a little close. We got about 4 minutes. So in these 4 minutes, maybe finish up the question you're on. You may want to jot down if you have any homework to do. So what I need you to have done by Friday is you should have the book work completed. If you don't have it completed and or you need help on it, please utilize the website and those videos, but it should be completed. No more class time set aside for that. And then the 2 worksheets you picked up today, both of those make up number 5. Please do the first one as a practice quiz to give yourself an idea of where you stand. And as a reminder from the start of class, our quiz is not next class now. It'll be the class after, so we got a little bit more leeway here. But once you do that, find a good stopping place. If you borrowed one of my calculators, I need it back. The books you can put back on your way out. If you borrowed any highlighters, put those back. I just ask that you don't line up at the door. But you're welcome to start getting ready to move on.
Wait, are we supposed to do both of these?
You need to do at least this one before Friday. This one you need to That's perfect. Anywhere up there is great.
I don't know, I'll check my answer later, but do you think I'll find the right track?
I got it. Oh, do you need it for other classes?
Yeah.
Okay. And then you'll still have it on Friday. Dude, first one here. Did you get lost yesterday?
Yeah.
I understand.
I was
First
on,
week is kind of tough.
I was on that side. I went like around.
Yeah. Give it a couple weeks, you'll
You'll be an expert.